Deep learning is a type of machine learning that uses artificial neural networks to model and solve complex problems. These networks are inspired by the human brain and are made up of interconnected units called neurons or nodes. Let's consider a single neuron in a deep learning network. This neuron is like a tiny decision-making unit. It receives input from other neurons, processes this input, and then passes its output to other neurons in the network. Imagine the neuron as a tiny post office. It receives letters, inputs, from various places, other neurons. Each of these letters has a certain importance or weight attached to it, which is determined by the network during the learning process. The post office neuron then adds up all these letters, inputs, taking into account their importance, weights. Once the neuron has all the weighted inputs, it applies a rule, known as an activation function, to decide what to do next. This rule might be as simple as, if the total is above a certain amount, pass on a letter output to the next post office neuron. If not, don't pass on anything. The power of deep learning comes from having a large network of these neurons, all working together and passing information between each other, to make sense of complex data and make predictions or decisions. Each neuron contributes a small part to the overall decision, but together, they can solve very complex problems. We use TensorFlow, which is a package from Google Brain and short for TF, to create a simple linear model. TensorFlow is a powerful library for numerical computation, particularly well-suited for large-scale machine learning. It's designed to work with artificial neural networks, and it's what powers a lot of Google's own capabilities like image and speech recognition. In the code you provided, we're creating a model that's just about as simple as it gets in TensorFlow. The tf.keras sequential function is used to initialize a linear stack of layers, which means the layers are stacked on top of each other where each layer has exactly one input tensor and one output tensor. Inside the brackets of tf.keras sequential, we define the architecture of our model. In this case, we're adding a single layer to our model using tf.keras.layers dense. The dense layer is the regular deeply connected neural network layer. It's the most common and frequently used layer. Dense layer does the below operation on the input and return the output. The units equals 1 argument means that this layer will have only one neuron. The number of neurons in a layer is a measure of the layer's capacity to learn from data. Since we only have one neuron, this model is only capable of learning very simple patterns. In essence, this code is creating the simplest form of a neural network, a single-layer network with only one neuron. This is equivalent to a linear regression model, where the output is a linear combination of the inputs. It's a good starting point for understanding how TensorFlow works, but in practice, you'd typically use more layers and more neurons to model more complex patterns in your data.